A Unix watch command does not get enough glory. All it does is run another command again and again in a loop. But that gets you interactive, streaming real-time feedback on anything you can represent as a Unix pipeline. If Unix or watch is not available to you for some reason, you might explore an alternative like Watchman that runs on other systems like Windows. Today, we'll be doing all of our work in a Docker container, just so that there's nothing that particularly depends on my system. But these same commands should work on any Unix. So now we're in the Docker container. We can run watch with a command like echo hello, and then watch will run that command and show us the output, and rerun it every 2 seconds, meaning watch runs the command, then waits 2 seconds, then runs it again. It's not like a cron job that runs at specified times. You'll never have 2 instances of the command running at the same time. The 2 seconds is a latency between runs. Of course, this isn't interesting because the output of echo hello never changes, but suppose it's something like date, whose output changes. So we're seeing the output change every 2 seconds because that's when watch is running the command. We can change that latency and make it something like 1 second with the -n flag. And then we see the output update once per second. You can even make this fractional. Now with date, that won't show us anything interesting because date's default output only updates once per second anyway. But we can tell date that we want to see down to the 10th of a second. And then we can see that watch is running it roughly twice per second. So now let's do a little development. Let's write a factorial function in Python. And we'll see how watch is helpful with that. So I'm going to open another tmux pane here, where I'm going to run my watch command. This is often called a watch window. It could be another terminal window. It can be a panel in your IDE or anywhere you can run a Unix command. So I'm going to tell it I want to run with 200 millisecond latency. I'm going to pass -t to avoid that title line that shows the timestamp and the frequency. I don't need that. I'm going to run Python 3 on factorial.py. That'll be what we call our script. And of course, there's an error because it doesn't exist yet. So I'll go over here and create it with Vim, and as soon as I write the file, the error goes away. No output because no code. If I add some code and I write the file, then I see the output. And if I change the file and I write it, then I see the output. Now I'm going to tell Vim that I want to update automatically in real time, just so I don't have to keep writing it. I really want this to be a streaming output as I change the code. There we go. That seems to be working. So now let's start writing the actual factorial module. We'll start with a doc string. You can see also I get error reports in real time, which are very useful. Lots of information. So this module defines a function to compute the factorial of a given integer. If run as a script, it prints the factorials of all integer arguments. Cool. Let's add some boilerplate. If name is main, right? So that we can distinguish whether we're being called as a script or imported as a module. And in there we'll just call a main function. Oops. We don't want to define it there, we want to call it there. And the watch output tells us immediately that main is not defined yet. So we'll go over here and define main. And in there, let's start by just printing the factorial of a hard-coded value like 42. And factorial is not defined yet. Name factorial is not defined. So then we'll define that. You can see that we're getting some of the spirit of test-driven development here, but without having even written any tests. We just got very, very rapid feedback. So the factorial of n will return the product of the integers 1 through n. N must be a non-negative integer. Cool. And then we see none because factorial isn't returning anything meaningful. If we were to return a hard-coded value, that's what we would see. But we actually want to implement this, so we'll say return the product of the range of numbers. We can start from 2 instead of 1 because multiplying by 1 doesn't do anything. We'll say n there. And product is not defined, so we'll define a product function. Python has some, but it doesn't seem to have product. So the product of some numbers will return the result of multiplying the specified, so the given numbers together. Return 1 if numbers is empty. Cool. implement this functionally as a reduction. So we can say this is the result of reducing the multiplication operation. Multiplication operator over the numbers with an initial accumulator value of 1, because that's the multiplicative identity. Reduce is not defined. So finally, we've hit bedrock, and we can start importing library functions. So in the standard library, we can say from functools, import reduce, and from operator, import mul. There we go, and we get a nice big number. So is that the factorial of 42? I don't know that off the top of my head. So let's check one I do now. Let's say 5, which I know the factorial of 5 is 120. Uh-oh, we're saying 24, not 120. So there we go. Already we found there's something wrong. We haven't written a test yet. I didn't even leave my editor at any point. But thanks to watch, we get the immediate feedback that lets us debug as we're developing. So the problem here is that range needs to take n plus 1, not n. Cool, so now we see 120. At this point, let's go ahead and add a test. So again, I will open another watch window just to run the tests. So I want my output for my script run, but I also want the unit tests running off to the side. So I'll say, again, 200 millisecond latency, again, no title line. And this will be, actually, I can just run PyTest. Okay, no tests ran because there are no tests yet. I'm just going to call my test file, testfactorial.py, and test factorial will simply assert that 120 is indeed factorial of 5. And when I write that, you see the failure because I have not imported factorial. But before we even fix that, there's something bizarre going on with PyTest. Its output is black and white. Whereas if I were to just run PyTest without watch, I would have nice color output, which is especially useful if you have error messages and you want to see where the problem is. So the problem here is that Unix commands ordinarily output color codes only when they're speaking directly to a terminal. So they need to be told when one command is calling another that they should go ahead and use color codes if we believe it's safe to do so. So in this case, we know it is, but we're going to have to tell watch, yes, we want you to forward the color codes from PyTest if it outputs them. And then we need to convince PyTest that it is actually speaking to a terminal, so it will output its color codes. The best way to do that is with the Unix script command. Script will create a pseudo terminal for PyTest. We can tell it -q because we don't want any output from script itself on the screen. C because we're going to give it a command. The command is PyTest. A script ordinarily writes output to a file as well. We don't need that, so we're just going to say dev null. So there we go. Now we have our nice color output. And when we fix this by saying from factorial import factorial, as soon as I write the file, the tests pass. Great. So now let's go back to our code and make good on the module docstrings promise of parsing command line arguments. So we'll need from sys to import our argument vector, argv. And then here, main, instead of printing a couple of hard-coded values, we'll, for each integer n, in the result of mapping int coercion over the arguments after the first one, which is the program name, print the factorial of n. Okay, so no error, no output though, because no input. So let's kill the watch command, Control-C, that's how you ordinarily interrupt it, with Control-C. And now I'm going to give it some arguments. Let's say 3, 5, 12. And there we go. There's some plausible looking factorial outputs. If I want to change that, I have to Control-C it again and change the command line, 20. And I get different output. So that works, but it's not useful because it defeats the point of having watch if I have to keep editing and rerunning the same command. The whole point of watch is to run the command automatically. So we're going to use a little magic here where we take this entire command and we make it a string, and now watch will treat it as a snippet of shell script. So then I can, instead of passing these hard-coded arguments, say the result of catting the file args. There we go. And it tells me args no such file or directory, because there is no file called args. And that's true, but in my editor, I can create that file. So I'll split args. As soon as I write it, the problem goes away. And I'm going to do the same thing as I did with the source code. I'm going to tell Vim that I want changes to be applied immediately. So now as I add arguments in this file, or remove arguments, I see the output update in real time. Now, you may think that this only works for small programs. It works for surprisingly large programs. I also use this with Rust and C++ that have heavyweight compilers, and it works surprisingly well up to programs that are sizable. And even when the programs are too big to get you real-time feedback, you can usually carve out a piece. You can run a small test program that exercises enough of the code for you to get this kind of experience, which is just, there's no substitute for real-time feedback like that. You may also be thinking that it's using a lot of CPU. It's really not. So if we run top, we got PyTest. We got PyTest using a quarter of the CPU in this Docker container. And then it went down. You can see that it's not in general because the load average is very low. So we can try making it work for a living here. Let's give it 1,000. What's the factorial of 1,000? Okay, there. And we still get very rapid feedback. My goodness, that is a large number. Okay, so now it's working. If we run top, 60% of the CPU that PyTest was using, we happened to catch it. But no, we got lucky and we saw PyTest doing something. But the actual 5 times per second computing those factorials is using essentially 0 CPU. It's using less than top. So that is safe and nice. There's one more thing I want to show you, which is the -d flag. So -d means show me a diff. Show me where the changes are relative to the last output. So now, if I make a change here, like let's make this 50, watch shows me which line changed. It flashes it. Okay. If I add some, let's add. There we go. Flash them. That flashing is so quick. Sometimes when I do this, I'll actually slow it down. So instead of 200 milliseconds, let's make this 500 milliseconds. And then you have a chance to really see where the changes were. If you change it in the middle, then of course all the subsequent lines changed because they got pushed down. Okay, that is the Unix watch command, and I hope that you found this useful. Thanks for watching.